Okay, for example 7, find an equation of the tangent line to the curve x squared y squared equals y plus 2 squared times 9 minus y squared at the point square root of 6 square root of 2 comma 1. So it's our basic question we've been asked the whole year here. Find the equation of the tangent line. Looking at the structure here, that looks a little bit intimidating, if I may say so myself. I'm looking, the left-hand side looks friendly. X squared, y squared, that's a simple product rule. We can handle that. This is also a product rule, but this has a squared on it, so we have to do a chain rule and differentiate that one. And to me, this side here looks just not very inviting. So again, I'm going to think, is there some algebra I can do to make this problem simpler? Okay, what do you guys think? Any thoughts as far as making this a simpler problem to work on? Anything we can do algebraically to make this problem be modified to something different?
Do FOIL on y plus 2.
FOIL y plus 2, let's start there. So x squared, y squared equals. So if I'm doing y plus 2 the quantity squared, this is binomial squared, so it's going to be y squared plus 4y plus 4. And that's being multiplied by 9 minus y squared. Okay. I just took the chain rule out of the picture. Because now I don't have an object squared, I just have an object to the first. So this thing has a derivative, this thing has a derivative. So if I do 1d2, this derivative is basic. If I do 2d1, that derivative is basic. Up here when I did 2d1, I have to use a chain rule. Alright? So just immediately, just by doing that one thing there, it made it an easier problem. Chain rule just got out of the picture. Next. This is a product, right? Product rule is necessary. But the 1 and the 2 are kind of bulky, right? A little ugly to look at. So the other thing I could possibly do here to make this maybe simpler would be to take 9 times all this stuff and y squared times negative y squared times all this stuff, simplify that out completely. So just have a bunch of terms without all these parentheses in the way. So let's try that. That gets me x squared y squared equals, or if I do the green multiplication first, 9 times everything is going to be 9y squared plus 36y plus 36. Now when I multiply the y squared, notice it's negative y squared. Be careful that minus sign is there. Negative y squared times y squared is negative y to the 4th. Negative y squared times 4y makes negative 4y cubed. And negative y squared times 4 makes negative 4y squared. Okay. Now obviously 9y squared and 4y squared can be combined, right, like terms. All right. But just take a look at the structure. This requires chain rule. This requires product rule. Notice this. Power rule, 0. Power rule, power rule, power rule. Everything's power rule. So just like that, 2 basic algebra steps, squaring a binomial, doing some polynomial multiplication. We've simplified this down to a product rule combined with a chain rule, into just a product rule, into just a bunch of power rules using algebra. Again, algebra can be your friend in calculus, let it be. X squared, y squared on the left, still a product rule, can't avoid that. But over here, if I go descending order, negative y to the 4th minus 4y cubed plus 5y squared plus 36y plus 36. Just like that, I'm down to a pretty basic, easy equation to differentiate. It makes the problem overall easier to do. And that thought process is what's missing from a lot of you. If you allow yourself the algebra thought and thinking about what can I do with algebra to make this problem into an easier structure, that's going to speed you guys up. Because again, that took, I mean, honestly, to do that, this and this on your paper, I'm guessing for you guys 45 seconds, maybe. That 45 seconds takes you from a 2 to 3 minute long derivative into about a 25-second long derivative. All right, so you're saving yourself time in the long run by doing this. Oh. How did that 9 minutes? Why not get in there? It's weird. Is this connected there? Actually, this one won't grab. Alright, so now if we go differentiate this. That's function 1, that's function 2. And again, that's just a necessary thing. You don't have to underline it so much on your paper, but you have to mentally establish a function 1 and a function 2 and use the product rule. It really forces you to think about the product rule as you do it too. So if I do function 1 times the derivative of function 2, the derivative of y squared is 2y. I'm differentiating a y expression, so I've got to put a dy dx on it. The product rule always has a plus sign in the middle. Then I do function 2, that's y squared, I don't care about that. I differentiate x squared, that's 2x. That's a function of x, so I don't have to put anything extra on it. So 2x is its derivative. On the right-hand side, everything's a function of y, right? So this needs a dy dx, this needs a dy dx, this needs dy dx, this needs dy dx. That's just going to be 0. So I'm going to get negative 4y cubed dy dx, negative 12y squared dy dx, positive 10y dy dx, positive 36 dy dx, and then 0, we're not going to write it down, thankfully, because I ran out of room. Okay? Now, I just got done chastising the book for being all random about where they put things. I would probably move dy dx to the right this time, because everything's dy dx except for this one term needs to go over there. It's easier to do that. So let me do that first here. So this right here is going to stay on the left-hand side, so I'm going to get 2xy squared stays on the left. On the right, I'm going to get a whole bunch of stuff, dy dx, right? Let's start with what I'm moving. So I'm moving this thing over to the right. It's got a dy dx attached to it, so x squared times 2y, better known as 2x squared y, is moving over to the right. And since it's moving, we're going to make it negative. Just kind of beautify the term a little bit. X squared times 2y is right, but 2 out in front times x squared y is a better way of looking at it. Again, it's positive on the left, move over to the right is a negative. Everything on the right is the sign it is. Everything on the right contains a dy dx, which again we've already accounted for by putting that outside the parentheses. So I'm just going to get a minus 4y cubed, a minus 12y squared, a plus 10y, and a plus 36 all in the parentheses. And again, that's one corner that is really easy to cut. It's worth doing immediately. Other stuff you can cut corners as you go. You can kind of start seeing that, hey, this happens every time. So then you can kind of maybe cut out a step or something when you see something happening every time. Make some hypothesis like that, and then see if you can start getting right answers. And then finally, all this stuff times dy dx equals that, so I got to divide that by this to get the derivative. So dy dx ends up equaling the 2xy squared on top over negative 2x squared y minus 4y cubed plus, or minus 12y squared plus 10y plus 36. Okay, now, if that were the problem, we'd be done. If it said find the derivative, we're done. What it asks us to define the equation of the tangent line. That's our slope formula. So once we've established the slope formula, now we need to establish the slope. Is everybody okay with all the work I got up here? Because I'm about to shrink some of it down. All that will be grouped together. Alright, so dy dx equals all that. So if I want to get the slope, I'm simply going to replace all the x's with 6 squared root of 2 and all the y's with a 1. So the slope equals 2 times 6 times the square root of 2 times 1 squared over negative 2 times 6 times the square root of 2 squared. For me, I like to square things in my head. 6 times the square root of 2 squared is real simple. 36 times 2 is 72. Whenever you're squaring this type of structure, square that and drop the square root, then multiply the results. 36 times 2 is 72. Y is 1. 1 cubed is 1. 1 squared is 1. 1 to the first is 1. 36 is 36. So after all that substituting, the only radical ends up on top, 6 squared root of 2 on top, which is fine. So altogether, if I simplify this thing, 2 times 6 squared root of 2 times 1 makes 12 times the square root of 2 on top. This makes negative 144 minus 4 minus 12 plus 10 plus 36. Negative 104 148, negative 160, negative 150, negative 114. That's 2 coming up. Everybody okay with negative 114 there? We agree with that? I don't know why I wrote a 2 a second ago, but I did for some reason. Didn't mean to. Okay, and then if I reduce this, looks like 6. Negative 2 times the square root of 2 over 19 is the simplified, still exact slope of this thing. So there's my slope. My point of tangency 6 squared root of 2 comma 1. So if I go to y equals mx plus b, 1 equals m negative 2 times the square root of 2 over 19.
May I have your attention, please, for an announcement? Your attention, please. There will be a beach out for the volleyball game tonight. Once again, students, we will be having a beach out night for the volleyball game tonight.
Don't forget that. Square root of 2 times the square root of 2 is 2, times 2 is 4, times 6 is 24, so negative 24 19ths is what we get out of that. 1 is the same as 19 19ths. Move the 24 19ths over. That becomes positive after the 19 19ths there, so b is equal to 43 19ths. So just like that, we get our nice, exact equation of the tangent line, negative 2 square root of 2 over 19, x plus 43 19ths. I'd be okay with decimals if you don't feel as comfortable with the radicals as I do. If you want to get a decimal approximation here, go 4 decimal places there. And if you're going to make that 4 decimal places, go ahead and make that 4 decimal places also. Get the answer like that. But if you can keep the radicals and make an exact answer, I prefer that.